In this video, we will be discussing about AS Level Physics Paper 2 Structure Question 2023 October-November Variant is 22 and the subject code is 9702. In question number 1, in the following list, underline all the quantities that are SI-based quantities. So, we know that electric current, time, temperature, luminous intensity, these are all SI-based quantities. But charge is an unit, while force is a derived quantity. Under certain conditions, distance s moved in a straight line by an object at time t is given by s is equal to half at square. And the total equation or initial equation would be s is equal to ut plus half at square, where a is the acceleration of the object. State two conditions under which the above expression applies to the motion of an object. So, as it avoids ut, that means initial speed is 0, thus u is 0, so this term is 0. Then acceleration is constant. For all these motion equations that we are using, such as s is equal to ut plus half at square, v square minus u square is equal to 2as, v is equal to u plus at, in all this equation acceleration is constant. Then the part C, the variation with time t of the velocity of the car that is moving in a straight line is shown by figure 1.1. Compared quantitatively, the acceleration of the car at time t is equal to 8 seconds and at time t is equal to 14 seconds in terms of magnitude. So as we can see that at time t is equal to 8 seconds, the magnitude of the car, we need to compare this magnitude and direction. So we can see that the gradient at time t is equal to 14 is more steep than the gradient at time t is equal to 8. Thus, as the gradient is more steep at this point, that means it has a larger magnitude of acceleration, while here the magnitude of acceleration is less. So acceleration at time t is equal to 8 is less because the gradient is less steep than compared to time t is equal to 14. And the direction, as the object is moving, if you compare this direction as positive, then object is moving forwards in this direction, while in this direction the object is moving backwards. That means both the objects are moving in opposite direction if we compare both of these two. Therefore the direction of the acceleration is opposite in time 8 seconds then compared to time t is equal to 14 seconds. Then determine the magnitude of acceleration of the car at time t is equal to 4 seconds. So at time t is equal to 4 seconds, as it is a straight line graph, so we can use the gradient formula, that is y2 minus y1 by x2 minus x1. So if we compare the point, suppose this point and this point, so y2, that is 20, minus 0, that is this point, by x2 minus x1, that is 12 minus 4. So the acceleration comes to be 5 by 2. So acceleration is 5 by 2 meter per second square. Then the car is at point x at time t is equal to 0. That means at time t is equal to 0, the car is at point x. Determine the magnitude of displacement of the car at x when time t is equal to 12. So we need to calculate the magnitude of displacement of the car at time t is equal to 12, that means at this time. So as we can see that this is a velocity time graph, and at this area the displacement is negative, while at this area the displacement is positive. So the total displacement would be positive displacement, that is displacement under this area, that is half into base into height minus displacement under this smaller area. So after subtracting we get a displacement that is 60 meter. The balloon is stationary and still in the air. A solid sphere is suspended from the balloon by the string as shown in figure 2.1. The volume of the balloon is 7.5 meter cube. The total weight of the balloon, string and the sphere is 65 Newton. So the overall total weight is 65 Newton. The upthrust acting on the string and the sphere is negligible, and the only upthrust is acting on the balloon. we need to calculate the density of the air of the balloon that acts on the balloon or surrounding the balloon. So we know that density is the mass per unit volume and weight is equal to mass into gravitational field strength. So mass is equal to weight by gravitational field strength. So we know the mass, and the volume that is given in the question is the volume of the balloon. So we have to use this only. After calculating, we get a density that is 0.88 kg per meter cube. Then the string breaks, releasing the sphere. The string breaks, releasing the sphere. State the magnitude of acceleration of the sphere immediately. It mentions about immediately. That means immediately after the spring breaks. So whenever it mentions about immediately, that means it is falling free fall. Its falling is free fall. And for free fall, we know that acceleration is 9.81 meter per second square. Then state and explain the variation, if any, the magnitude of the acceleration of the sphere when it is moving downwards before it reaches terminal velocity. So initially, after the release, the weight is only acting on the sphere. For the sphere, its weight is only acting, but as it is falling, its velocity increases, acceleration remains constant, that is 9.81, and so air resistance also increases. As air resistance increases, this causes the resultant force to decrease, and as resultant force decreases, therefore that means resultant force decreases in such a way that weight remains constant but air resistance increases. Therefore we know that resultant force is equal to weight minus air resistance. As it is moving downwards, so weight minus air resistance, so air resistance increases, as a result resultant force decreases, and since resultant force decreases, we know that resultant force is equal to mass into acceleration, so mass remains constant and acceleration also decreases. That is, air resistance increases due to increase in speed. This causes the resultant force to decrease. And so as resultant force decreases, acceleration also decreases until it becomes 0. That means the object would move with a terminal velocity where acceleration is 0. Sphere has a mass of 4 kg. Calculate the total resistive force acting on the sphere at the instant when its acceleration is 1.9 meter per second square. So we know that for the sphere, as it is moving downward, its downward force is weight and the upward force is air resistance. So weight minus air resistance is equal to mass into acceleration. So for the weight of the sphere, we know that its mass is 4 kg. So weight is equal to mass into gravitational field strength minus resistive force is equal to mass into acceleration. So we need to find the resistive force, and the resistive force comes to be 31.64, and for physics we have to give maximum of our answers to two significant figures. So we round off it to 32 Newton. 3. The vertical rod is fixed to the horizontal surface of the table. So the rod is fixed to the horizontal surface of the table as shown in figure 3.1. The spring of mass 7.5 gram is able to slide along the full length of the rod. So the spring is about to slide up the rod. The spring is first pushed against the surface of the table so that its initial compression of 2.1 cm. So the compression is 2.1 cm. The spring is then suddenly released so that it leaves the surface of the table with a kinetic energy of 0.048 joules. So we have given the kinetic energy and its compression or extension, and then it moves up the rod. So after it gains kinetic energy, it moves up the rod. Assume that the spring obeys Hooke's law. As it obeys Hooke's law, that means force is directly proportional to extension, and that the initial elastic potential energy of the compressed spring is equal to the kinetic energy of the spring. So initial elastic potential energy is equal to the kinetic energy. You have to remember this of the spring as it leaves the surface of the table. Air resistance is negligible. That means there is no work done against air resistance. By using the initial elastic potential energy of the compressed spring, calculate the spring constant. So we know that elastic potential energy is equal to half Fx or half kx x square, where x is the extension, F is the force, and k is the spring constant. So we need to find the value of spring constant, and we know that initial elastic potential energy is equal to initial kinetic energy. So we need to calculate the value of spring constant. So spring constant is equal to elastic potential energy into 2 by x square, where elastic potential energy is same as kinetic energy, so its magnitude would also be the same, that is 0.048. After calculating, we get an spring constant of 220 Newton per meter. Also, as the extension here is given in centimeter, so we must convert it to meter because the SI unit is in meter. And for the spring constant, as it is given to approximately 5 significant figures, but we need to give our answer to 2 significant figures. So converting it to 2 significant figures, it becomes 220, that is 220 Newton per meter. Speed of the spring as it leaves the surface of the table. So to calculate the speed of the spring, it mentions about as it leaves the surface of the table. That means the initial speed. And we know that initial elastic potential energy is equal to initial kinetic energy. And we know the value of kinetic energy, that is 0.048. We need to calculate the value of speed. We know the mass that is given earlier, that is 7.5 gram. We must need to convert it into kilogram. So 7.5 by 1000 is in kilogram. Then the speed comes to be 3.57, and correct to 2 significant figures that we have given our answers earlier, it would be 3.6 meter per second. The spring rises to its maximum height. Spring rises to its maximum height. Suppose this is the spring, it rises to its maximum height up the rod from the surface of the table. This causes the gravitational potential energy of the spring to increase by this amount. This is the increase in gravitational potential energy. Calculate for the movement of the spring the increase in height. So we know that gravitational potential energy is equal to mass into gravitational field strength into height, and we know the value of mass, that is 7.5 gram. We must convert it to kilogram, and the gravitational field strength is 9.81, so the height comes to be 0.53 to 2 significant figures. Calculate the average frictional force exerted by the rod on the spring as it moves. So, though it mentions in the question that air resistance is negligible, but the frictional force due to the rod on the spring acts. And so, as the spring is moving upwards, its frictional force due to the rod is acting downwards. So we need to calculate the magnitude of the frictional force. So we know that initial elastic potential energy or initial kinetic energy is equal to final gravitational potential energy as it rises up the ground, that is this gravitational potential energy, and work done by friction. So work done by friction would be 9 into 10 to the power negative 3. So we know that work done by friction is equal to force into distance. So the average frictional force comes to be force by distance, and the distance we know is the increase in height. Since the spring is moving vertically, so its increasing height would be the distance. So that is, the distance is 0.53. After calculating, we get our answer as 0.016, and correct to 2 significant figures, that means 1, 2, that would be 0.02. And this answer is given correct to 1, 2, 3, 4. 1, 2, 3. This answer is given to 3 significant figures, and we convert it to 2 significant figures, that is 0.02. It is replaced by another rod that exerts negligible frictional force. Now for this new rod, there is no frictional force. That means initial kinetic energy would be equal to final gravitational potential energy, as there is no frictional force, so no work done against resistance due to frictional force. The initial compression x of the spring is now varied in order to vary the maximum increase in height. So extension is varied to vary the height of the spring after leaving the surface of the table. Assume that the spring obeys Hooke's law. That means force is directly proportional to extension. On the figure, sketch the graph to show the variation of x against h numerical values are not required. We know that initial kinetic energy is equal to initial elastic potential energy, and so the final initial elastic potential energy is equal to final gravitational potential energy since there is no resistive force. So elastic potential energy is equal to half Fx or half kx square, and gravitational potential energy is the mass into gravitational field strength into height, and we know that mass for the object remains constant, gravitational field strength is constant, half is always a constant, and spring constant, it is mentioned its name, that is constant. So height varies directly proportionally with extension square, that is height is directly proportional to extension square. And for directly proportional graph, we know that it increases in such a way that height increases as shown. Suppose if it is a height is directly proportional to just extension, then it would be straight line, but since height is directly proportional to extension square, so the line would slightly tilt toward the x-axis. Suppose the line would slightly tilt toward the x-axis, that means this axis. The line would slightly tilt towards this side. Or to draw it more specifically, it becomes like this. Tilt towards the x-axis and then increases. Tilt towards the x-axis and then increases. And for inversely proportional graph, suppose that height is inversely proportional to extension, then the graph would something look like this, that instead of being a straight line, since height is inversely proportional to extension, so the graph would be like this, sloping downwards. And if instead of height is directly proportional to extension square, if height square is directly proportional to extension, that is just the extension and not the extension square, so height square is directly proportional to extension, the graph would look like this, that is height against extension graph would look like this, as it is a square. So instead of being a straight line, that is this straight line, the graph would slightly tilt towards the height axis, that is this axis, and the graph would look like this. For part A ball Y moves along the horizontal frictionless surface. So the surface is frictionless, that means there is no friction, and collides with the ball Z. So ball Y moves and collides with ball Z, as illustrated in figure 4.1 and 4.2, that is before collision and after collision. Ball Y has a mass of 0.25 and moves initially along line PQ. Ball Z has a mass mz and is initially stationary, that means its speed is 0. Then after the collision, ball Y moves with a final velocity of 3.7 meter per second, so 3.5 meter per second at this direction, that is at an angle of 27 degree to the horizontal 2, and the horizontal is PQ, and the ball Z has a final velocity of 5.5 meter per second at an angle of 4.44 degree to line PQ. Calculate the component of the final momentum of ball Y in the perpendicular distance to line PQ. So we need to calculate its final momentum of ball Y. So this is ball Y, and we know that momentum is equal to mass into velocity. So its mass is 0.25 and its perpendicular velocity is 3.7 into sine 27 degree. So the total momentum would be its mass, that is 0.25 into 3.7 sine 27 degree. So after calculating, it comes to be 0.42, correct to two significant figures. By considering the component of the final momentum of each of the ball in the direction perpendicular to PQ, calculate mz. So in the question, it refers to by considering the component of final momentum. So the final momentum is in this direction, that is perpendicular to PQ, we need to calculate mz. So by considering this information only, we can conclude that the momentum of P moving upwards is equal to the momentum of Q moving downwards, since we have to just consider this thing, and by considering this we can give this conclusion only. And since it is a one mark question, so thus we just consider the momentum at upwards direction is equal to the momentum at downward direction, since we just need to consider these two things. After considering, we know that the momentum of upward of P, we know that, and the momentum of Q would be its mass, that is mz, into its velocity and sine 45 degree. So after equating, we get the mass mz, that is 0.1099, that is approximately, correct to two significant figures, it becomes 0.11 kilogram. During the collision, the average force exerted on y by z is Fy, and the average force exerted on z by y is Fz. Compare the magnitude and the direction of Fy and Fz. Numerical values are not required. So we know that for two objects that are colliding by Newton's third law of motion, if body A exerts a force Fab on body B, then body B will exert an equal and opposite force on body A. Thus, as the forces are equal and opposite by Newton's third law, so it would be equal force, but the direction is opposite. Two blocks A and B move directly towards each other. As the blocks are moving towards each other, along the horizontal frictionless surface, so the surface is frictionless, as shown in the figure. The blocks collide perfectly elastically. That means speed of approach is equal to the speed of separation. Before the collision, block A has the speed of 4 meter per second and block B has the speed of 6 meter per second. After the collision, block B moves back along the original path. That means block B moves along its original path, that is this path, with a speed of 2 meter per second. That means, as after collision, suppose these two objects collide. After collision, since B is moving in this direction, this causes A also moving in this direction. And as we know, since objects are colliding perfectly elastically, so speed of approach is equal to the speed of separation. And to calculate this, you have to remember that if the objects are moving in opposite direction, suppose A is moving in this direction while B is moving in the opposite direction. Since the objects are moving in opposite direction, so we have to plus their speed. And suppose if A is moving in this direction and B is also moving in this direction, since the objects are moving in the same direction, so we have to minus their speed. For same direction we have to minus, and for opposite direction we have to plus. So since A is moving in this direction while B is moving in the opposite direction, so we have to plus their speed. Also, as B is moving in this direction and A is moving in also this direction, since they are moving in the same direction, so as they are moving in the same direction, so we have to minus their speed. That means there will be a minus. So after subtracting, the answer comes to be 8, that is 8 meter per second. So in summary, only for perfectly elastic collision, if the objects are moving in the same direction, then we have to minus their speed. If the objects are moving in opposite direction, then we have to plus their speed. Suppose these two objects are moving in opposite direction, therefore we have to plus their speed, and these objects are moving in opposite direction, therefore we have to, these two objects are moving in same direction as represented by this arrow. So since they are moving in same direction, so we have to minus their speed. Question number 5, part A, the beam of vertically polarized light. So the light is vertically polarized. Okay, it's incident normally, that is perpendicularly on the polarizing filter as shown. Vertically polarized light is incident normally on the filter. The transmission axis of the filter is initially vertical. So as the transmission axis is initially vertical, that means initially all the light that is entering is passing straight through, since the transmission axis is vertical. So the transmission rate is maximum. The filter is then rotated through an angle of 360 degree, while the plane of the filter remains perpendicular to the beam. On figure 5.2, sketch a graph to show the variation of the intensity of the light transmitted in the transmitted beam with the angle through which the transmitted axis is rotated. So as we know that it is the graph of intensity of light that is passing through the filter and the angle at which the filter is rotated. So we have given 1, 2, 3, 4, 5 angles. So initially when the plane is vertical, we have as the light is vertically polarized, so maximum light is passing, so we get a maximum value. Then again at 180 degree it passes half its resolution revolution it passes half its revolution, and again it becomes straight, because if we rotate something, that is we suppose this square shape object, and if it is rotated 180 degree, then again it becomes vertical, just it becomes upside down. As it becomes vertical and the light is vertically passing, therefore we get a maximum value, and at 360 degree the transmission axis again returns to its original position, that is at this position, and since the transmission axis is now again vertical and the light is vertically passing, therefore we get a maximum value. But for 90 degree, since initially it was vertical, but after it becomes 90 degree, it becomes like this shape at this position. Suppose at this position the axis becomes at this position, that means the axis is parallel, the axis is in this direction and the light is passing in this direction. Therefore since the line of axis is perpendicular to the direction of light travel, therefore no light would pass through and the value of intensity is 0. Similarly at 270 degree, the axis is, suppose the axis is like this and the light is passing perpendicularly. Therefore as the light is passing perpendicularly, so no light would pass through, since the line of axis is perpendicular to the direction of light travel. Therefore no light would pass through. To summarize this, initially vertically polarized light is passing, and since the transmission axis is vertical, therefore maximum intensity of light is passing, and when the transmission axis is 180 degree, it is also vertical, and 360 degree it is also vertical, therefore maximum amount of light is passing. But when the axis is rotated 90 degree or 270 degree, it becomes horizontal and light is passing vertical. Therefore as a result, no light would pass through and the intensity becomes 0. Thus our graph would something look like a cos curve. The intensity of the light incident on the beam is 7.6 watt per meter square. So intensity that is incident is 7.6, and of the filter at an angle of theta to the vertical, the light intensity that is transmitted is 4.2 watt per meter. So the initial intensity that is incident, that is IO, is 7.6, and the intensity that is passing is 4.2, that is after it passes. So we know the formula, that is I is equal to IO cos square theta. By using this formula, we find the theta that is 42 degree, correct to two significant figures. What is meant by diffraction of a wave? So diffraction is the spreading of wave into a geometric pattern as the wave passes through an edge or a slit. That means you must remember to write into a geometric pattern. When you are giving the description or the definition of diffraction, that is spreading of wave into a geometric pattern, spreading of wave into a geometric pattern as it passes through an edge. As it passes through an edge or an obstacle. So spreading of wave into a geometric pattern as it passes through an edge or an obstacle. So then, in part C, a beam of light of wavelength 4.3 into 10 to the power negative 7 meter is incident normally on a diffraction grating in air. So we have given its wavelength, and we know the formula for diffraction grating is d sine theta is equal to n lambda. So a third order diffraction maximum is incident at an angle of 68 degree to the incident beam of light. So we have given the third order, that is the value of n is 3, and the angle is 68 degree, that is theta is 68 degree, and we need to find the spacing, that is the value of d. So we need to find the value of d. We have given the value of theta, the value of n, and the value of lambda. So d sin theta is equal to n lambda. So d is equal to n lambda by sin theta. So D comes to be 1.4 into 10 to the power negative 6, correct to two significant figures. Determine a different wavelength of visible light that will also produce the diffraction maximum at an angle of 68 degrees. Since it is a beam of light that causes the diffraction to at an angle of 68 degree, so it mentions about another beam of light. That means as it is third order maximum, so we have to choose second order maximum light. That means one order before it, because as we know that it defines us to give the maximum diffraction, and so maximum diffraction occurs only when the value of n is less. N is less, that means as diffraction occurs maximum, that means a wave diffracts maximum. That means the value of n is less and the lambda is more. That means the second order maximum. So after substituting the value, we get the value of lambda as 6.5 into 10 to the power negative 7, correct to two significant figures. L wire has a resistance per unit length. That means here we have given two informations, the resistance and the length is 1 meter. The wire has a uniform cross-sectional area. Calculate the resistivity of the metal. So we know the formula, that is resistance is equal to resistivity into length by cross-sectional area. We need to find resistivity, that is the rho. So resistivity is equal to resistance into area by length. We know the resistance is 0.92 ohm. We know that the length is 1 meter and we know the area. So the resistivity comes to 4.9 into 10 to the power negative 7, correct to two significant figures. A battery of EMF E and negligible internal resistance is connected in series with a fixed resistor and a light dependent resistor LDR. The resistance of the fixed resistor is 1400 ohm. This has a resistance of 1400 ohm. The line intensity of the intensity of the light. So the resistance of the fixed resistor is given. The intensity of the light illuminating the LDR causes it to have a resistance of 1600 ohm. So this is the LDR, that is light dependent resistor, and it has a resistance of 1600 ohm. A voltmeter is connected across the LDR, reads 6.4 volt. So the voltmeter reading is 6.4. Show that the current in the LDR is 4 into 10 to the power negative 3 ampere. We know that the resistance is equal to voltage by current, that is current is equal to voltage by resistance. We know the value of voltage and the resistance, that is 1600 ohm. So after calculating, we get our answer as 4.0 into 10 to the power negative 3, corrective to this two significant figures, and this would be wrong because there is no 0.0. So it would be 4.0 into 10 to the power negative 3 as given. Calculate the number of free electrons passing through the LDR in the time 3.2 minutes. So to find the number of electrons, first of all, we know the value of current, and we know that current is equal to charge per unit time. So charge is equal to this much charge. We know that 1.6 into 10 to the power minus 19 coulomb is equal to 1 electron, that is given earlier in the question. In the question paper, that is 1 electron is equal to 1.6 into 10 to the power minus 19 coulomb. 1 electron is equal to 1.6 into 10 to the power minus 19 coulomb. So this much coulomb is equal to 1 by 1.6 into 10 to the power minus 19 into the value. So we get our answer as 4.8 into 10 to the power 18, correct to two significant figures. Calculate the EMF E. So EMF is equal to current into resistance, and we know that current in the series circuit remains constant, that is 4 into 10 to the power negative 3, and current into resistance, so the resistance is, as the two resistors are arranged in series, so we have to add the resistances. There is 1600 plus 1400, and the total EMF correct to 2, and the total EMF comes to 12 volt, correct to two significant figures. Then determine the ratio of power dissipated in the LDR and the power dissipated in the fixed resistor. We know that power is equal to VI, or power is equal to I square R. So we know the value of current, that is 4.0 into 10 to the power negative 3. So I square will cancel each other out, and so the ratio becomes that 1600 by 1400, since the resistance of LDR is 1600 and the resistance for the resistor is 1400. So the ratio value comes to 1.1, correct to two significant figures. Metal conditions change, causing a decrease in the resistance of the LDR. So resistance of the LDR decreases. That is a light dependent resistor, and we know that resistance is inversely proportional to temperature. For this is the resistor this is the LDR, that is a light dependent resistor and not the thermistor. So resistance is inversely proportional to light intensity, that is for LDR or light dependent resistor, resistance is inversely proportional to light intensity, and if it is thermistor, then it would be resistance is inversely proportional to temperature. State whether there is a decrease, increase or no change to the light intensity illuminating the LDR. Since the resistance decreases, therefore the light intensity increases. Also, as we know that resistance is equal to voltage by current. Since resistance decreases, therefore current increases, since resistance is inversely proportional to current. Reading on the voltmeter. As we can see that resistance is directly proportional to voltage, so as resistance decreases as given in the question, therefore voltage also decreases. Following list, underline all the particles that are not fundamental. So before discussing this, let's revise some nuclear physics topics. Particles are divided into leptons and hadrons. Leptons are not made of quark, while hadrons are made up of quark. So hadrons are made up of quark, and thus it is affected by strong nuclear force, while leptons are not made up of quark, and therefore they are not affected by strong nuclear force. So hadrons are made up of quark and affected by strong nuclear force, but leptons are not made up of quark and so are not affected by strong nuclear force. Examples of leptons are electrons and electron neutrino. Electrons are represented by a negative symbol, and the electron neutrino that you need to know is represented by this symbol. And hadron is further subdivided into baryons and mesons. So hadron, that is the head of this group. Hadron. So hadrons are divided into baryons and mesons. Baryons are made up of 3 quark, while mesons are made up of 2 quark. Baryons can be made up of, so before discussing baryons, mesons are made up of 2 quark, that is matter and antimatter. And for baryons are made up of 3 quark, and the examples of quark such as up, down, top, strange, bottom quark, and the examples of baryons are protons and neutrons, as we can say that protons are made up of up down quark and neutrons are made up of up down quarks. And if we discuss about the quark, then up, top and charm, these all 3 quark have a charge of +2/3, while down, strange and bottom quark has a charge of -1/3 e, where e is the elementary charge, and all of them have a mass of u/3, that is u is the elementary mass. So u/3 all have the mass of u/3, but up, top and charm quark has a charge of +2/3, while down, stage, bottom quark has a charge of -1/3. We know that baryon and nucleon are made up of quark, so they are not fundamental particles, while antineutrino and positron are the examples of leptons, and therefore they are fundamental particles. So we need to circle the particles that are not fundamental, that are baryons and nucleons. A nucleus of thorium-230 decays in the stages by emitting alpha particle. Alpha particle has a charge of 2 and a mass of 4. That is this alpha particle. Charge of 2, mass of 4, and this is the alpha particle. And for beta particle, the charge is -1 and a mass of 0. Determine the total number of alpha particles and the total number of beta particles that are emitted during the sequence of decay from the nucleus of lead 206 to the nucleus of. So the decay occurs and that form the nucleus of 206. So this nucleus is formed from thorium. So we know that there is a change in mass number, and change in mass number occurs due to alpha particles, because here we can say that beta particles has a mass of 0, so emitting this has no effect on the mass, but alpha particle has a mass of plus 4. Therefore, emitting alpha particle would causes a decrease in mass. So first of all, we calculate how much alpha particle is emitted. It is 230 minus 206. So the answer comes to be 24. The decrease in mass in 24, and each alpha particle has a mass of 4. So if we divide this by 4, we get the number of alpha particles that are emitted, that is 6. So what is the number of beta particles emitted? Now the charge decreases, and as we know that when an thorium decays to a lead, that means whenever a substance decays by beta emission, its neutron changes to a proton and an beta minus particle. So neutron changes to a proton, and as we know that alpha decay causes a decrease in the proton number, that is as 6 alpha particles are emitted, so the total number of protons that is decreases is 12. So total proton decreases is 12, but here it is given that only 8 proton is decreases. So we should get a value of 12, but we get a value of 8. That means if we subtract 12 minus 8, we get a 4. That means 4 beta particles are emitted, and due to this 4 beta particles are emitted, the proton number increases by plus 4 since neutron is converted to proton and beta minus particle. So in summary, as the nuclear number decreases, this is caused by alpha particle. So after subtracting this and dividing by 4, we get the number of alpha particles that are emitted. Then we multiply by this value by 2, that is the number of alpha particles into 2, that is the total number of decrease in proton. So proton number decreases by 12, but we get a value of 8. That means therefore neutrons changes to a proton, and instead of decreasing by 12, it decreases by 8. That means the charge increases by plus 4. That is, instead of decreasing by 8, it decreases by 8. That means the charge increases by plus 4. That means 4 beta particles are being emitted. So it is the 4. The charge of negative 1e. Where is the elementary charge? The quark composition of the meson includes a charm quark, and we know that the charge of a charm quark is, this is actually charm antiquark, and whatever the charge of the quark, the charge of the antiquark is opposite. For example, the charge of a charm quark is plus 2 upon 3, so the charge of the charm antiquark would be negative 2 upon 3. So there is a charm antiquark. State and explain the flavor of one another quark of the meson. So it has a total charge of negative 1, and charm plus one other quark has a total charge of negative 1. So after equating this, we get the charge of one other quark, that is negative 1 by 3. And we know that down, strange or bottom quark has a charge of negative 1 by 3, while up, top and charm quark has a charge of plus 2 upon 3. And whatever the charge of quark is, if it mentions in the question that the charge of antiquark, then it is always opposite this value. That means if suppose a quark has a charge of positive negative 1 upon 3, then an antiquark has a charge of plus 1 upon 3. That means the value remains same, but the sign changes from negative 1 to plus 1 or from plus 1 to negative 1 due to the presence of anti in the quark.